So now we are going to look at problems of collisions, and you want to know that the collisions are of two kinds. One is called elastic collision, when the total energy of the system remains same or conserved, and second is inelastic collision, when the total energy of the system is not conserved, right? Especially when the two objects are moving and basically they get stick to each other, right? That kind of collision is inelastic collision. Okay, so let's look at the question and see how we can apply the law of conservation of momentum to solve these kinds of questions where the energy conservation does not work. Okay, so the bodies shown in the figure suffers a head-on collision and stick to each other. So whenever in the question they are saying stick to each other, this means this is an inelastic collision. Okay, and in case of inelastic collision, we cannot apply law of conservation of energy. Okay, so find their common velocity afterwards, right? So the only result we have is the law of conservation of momentum, which remains valid whether the collision is inelastic or elastic, right? So let's look at this. So there are no forces acting on the system in the horizontal direction, which means the momentum will remain conserved in the horizontal direction. Okay, that's the first thing we want to note, which means my initial momentum will be equal to final momentum for the system. Okay, so let's write down the initial momentum. Let's take the right side as positive direction and the left side as a negative direction. So with that in mind, with this sign convention we're able to follow for both the sides, right? And let's write down the momentum. So initial momentum mv, which is moving towards right, which is a positive quantity, right? Which is because it is moving towards right, and this 2m v by 2 towards left. So with a minus sign, 2m into v by 2, and you can see here mv minus mb, my initial momentum is equal to 0, and that should also be equal to my final momentum. Okay, so for the final momentum, because both the balls get stick together, we can write the mass. It's going to be m plus 2m, right? This is the final mass of the body when they stick together, and this is going to be v final, the velocity of the common object, which is m plus 2m or 3m. And we have just found that the initial momentum is equal to 0. So this will be also equal to 0 because the mass cannot be 0. My v final is going to be equal to 0. And this is how simply, without using energy conservation in case of an inelastic collision, we can solve this kind of question pretty easily. So now look at another question, the next one, where we are going to look at the elastic collision. Okay, so two masses moving in a straight line towards each other collide as shown in the figure. So this is my initial configuration, and after that the second one is moving with a 3 meter per second towards left, and we have to find whatever the velocity of this mass of 12 kg is, right? Whatever the v is after the collision. We know that the energy will remain conserved, right? Because it is an elastic collision, but it is not clearly given. So let's first try the law of conservation of momentum, right? And see what answer we can get, right? So again, my momentum of the system initial will be equal to momentum of the system, which is final. Okay, so let's take this side as positive, right side as positive, and left side as negative, and write down the initial momentum. So for the initial momentum, 4 kg into 24 towards right, so that's 4 kg into 24 plus, and this 12 kg into 2 towards left, so this is going to come with a minus sign, 12 into 2, and this is our initial momentum. Okay, so 24 into 4 is going to be 96 minus 24, right? And that will be our initial momentum. So that is going to be equal to 72, right? So 72 units of momentum towards right. Why? Because this is a positive number. Now, what is the final momentum? We can again use the same thing. This time, the first one is moving towards left, right? So this one is going to be equal to the final momentum, right? Moving towards left. The mass of the first one is 4. So 4 into 3. But this is going to come with a minus sign because it is moving towards left. Plus, we don't know the direction of the velocity of the second one, so we are just going to assume plus, and whatever the math comes will determine the direction. That's going to be 12 into v. Okay, the v of the heavier mass. This is minus 12 plus 12v is equal to 72. Now this will go on that side, add up. Basically, we'll end up with 84 12. So my V is going to be 84 by 12, and that is equal to 7 meter per second. Now this is a positive number, which means the heavier mass is moving towards the positive direction. So this has a velocity V, which is 7 meter per second, and this is towards right. Towards right. Okay. So whenever they're asking for the velocity, we have to provide the magnitude as well as direction. The magnitude is 7 meter per second, and the direction is towards right, and that will be our final answer.